Okay, hello Honor Chem kids. This is a video on oxidation states as we are learning a little bit about oxidation and reduction reactions. You have to know about something called oxidation states or what we call oxidation numbers. So sometimes you're going to hear those called, sometimes you'll be hearing them called as numbers as well. So I want you to realize and recognize that we're talking about the same thing. Okay, so when I'm taking a look at oxidation states keep track of the electrons in a redox reaction by assigning charges to various atoms in the compound. And what I have a picture here is a picture of chromium, so that's a capital C. And with the picture of chromium, there's different charges for chrome. So chrome can typically be at a +2 state, +3 state, or we could actually even have chromium in what we call a hexachrome state, which is a +6 state. As you learn more advanced chemistry, you have to kind of memorize colors and how they work with their oxidation numbers. But if you look at chromium and you think about where chromium is positioned on the periodic table, so if you're thinking about that, chromium exists right in here as a transitional metal. And remember that they can be what we call multivalent. Okay, so we're going to talk a little bit more about the multivalent charges of the periodic table, as well as the charges that would be within families within the periodic table as well. So we'll be talking about them. Okay. We're going to learn how to assign rules for oxidation numbers, and there are some rules that we're going to go over. The first one would be anything like a pure element. So you're talking about sodium, or if it's diatomic oxygen, it could be diatomic nitrogen. All of those are pure elements, so they would have an oxidation number of 0. The oxidation number of a monoatomic atom equals the charge. So if you're thinking about looking at the periodic table and you think about the elements that are in what we call the S&P block, or you kind of remember that from quantum mechanics, or what we call main group elements, those elements are usually pretty easy to determine their oxidation number. If you have two elements that you're trying to figure out what the oxidation element or number is, the more electronegative element is assigned the number that's equal to the charge. So that's also a very good one to memorize. Fluorine's always -1. Oxygen in this class is always -2. We very rarely will be working with peroxides, so we're just going to kind of ignore that. Hydrogen will always have an oxidation number of +1 when it is combined with other nonmetals. So I'll put down nonmetals here. If it's combined with a metal, then it's a -1. But most of the time, hydrogen is going to be equal to a +1. So hydrogen will be a +1. Elements in group 1 and 2 have charges of 1 and 2. When we have a compound and we have to sum the oxidation numbers, they're equal to 0. Unless it's a polyatomic ion, then that oxidation number has to equal its charge. Now I know that this probably sounds really confusing, but trust me, as we're going to go through a couple examples and you kind of know these general rules, it will be very easy. Also, you should make sure you kind of know these general rules. So you might want to look at page 631 in your textbook, because that's where the table's from, and you could take a look at it. So now what happens is that if we were thinking about the periodic table and we're thinking about where carbon sits on the periodic table, where, let's see, this would be group 13 and this is group 14, and so this is where carbon sits. You know, in what you learned in 9th grade was that group 1 was a +1, this is a +2, aluminum is a +3, carbon can be a +3 or a +4 or a -4, and it just kind of depends. And then where you went from there, it went -3, -2, -1, where this is nitrogen's compound, this is oxygen, and this is fluorine. So if we kind of extend out the periodic table, that group, that kind of makes sense. How do we know what the oxidation number is for carbon? It could be a +4, it could be a -4, it could be anywhere in between, and it kind of depends upon the compound and what else it is organized with. So that kind of does make a difference. So what I'm going to do now is I'm going to show you how to assign oxidation states for atoms in the following compounds or molecules. And then what I want you to do tonight is to do the homework assignment, which is basically just the same thing as assigning oxidation numbers. This is imperative that you know how to assign oxidation numbers because it makes balancing complex ions redox reactions so much easier when we're going to do that. So the first thing that I look at is I've got CO2. Okay, so as I'm looking at CO2, I know for sure from my list of information, I know for sure that oxygen in this class is always going to be a -2 charge. So if oxygen, so I'm going to write oxygen and I'm going to write a -2. If oxygen is a -2 charge and I have 2 of them, that means that carbon has to be a +4 charge. Okay, that's because a +4 and 2 -2s will balance each other out. Just on a side note, what if I had carbon monoxide? Well, we know that in this class, oxygen's always going to be a -2, but now the carbon's different. The carbon has a oxidation state of +2. So do you see how it depends upon what the compound is? Okay. Here we've got sulfur hexafluoride. Don't get freaked out. That sulfur actually can bond 6 times. We'll talk more about that in an AP chemistry class, but for now you just have to recognize that it's okay. Sulfur can bond 6 times. I'm looking at these 2 elements. I'm looking at sulfur and I'm looking at fluorine, and I'm trying to think, okay, which one would I start with my oxidation numbers? I'm going to go back to this rule here, which says, I'm trying to find it, rule number 4 right here says fluorine always has a -1 charge. So I can go and say for sure fluorine has a -1 charge. So if fluorine is a -1 and I have 6 of them, that means that sulfur has to be a +6. See, so that's not so bad. What about if you have a polyatomic ion, like the nitrate ion here? Well, the sum of these oxidation numbers has to equal this charge. So if I have oxygen, and I know oxygen's always a -2, and let's see, that would be -2 times 3, that would give me -6 total. That means that nitrogen has to be a +5, because if I put a +5 here and I have a -6, that's going to give me that overall negative charge. What if I have NO2? Oxygen's always a -2. Nitrogen then, in this case, has to be a +4. So pretty simple to do oxidation numbers. I'm going to give you one more, and that's going to have more than one element. So we're going to practice sodium bicarbonate. Okay, so we've got a lot going on there. Actually, I have a lot more. Here's where you're going to want to you're going to have to kind of think about some of the rules and figure out where they all fit in. The first one that I'm going to do is I know oxygen in this class is always a -2. So if that's a -2, okay, I have 3 of them, so the total on that is kind of a -6. So I kind of keep a running total of that below. I also know that sodium is a +1. And the reason why I know that is because when I look at my chart here, in rule number 7, it says the compound group 1 and 2 elements in aluminum all have an oxidation number of +1, +2, and +3 respectively. Well, sodium is in group 1. So we know that sodium is a group 1. So I'm going to say sodium is going to have a +1. Hydrogen is also a +1. And the reason why hydrogen is a +1 is because it is part of the polyatomic bicarbonate ion, which would be with all nonmetals. So you don't look at the sodium here because that's the cation. This is the anion portion of the element or the compound. And we know that H, C, and O are all nonmetals. So therefore, it has a +1 charge. So that brings us to carbon, okay? And I have to then kind of get these to equal a 0 charge overall. So if I have sodium with a +1 charge and hydrogen with a +1 charge together, these guys kind of make a +2. And my oxygen, because I have 3 of them, makes a -6. So that means that carbon has to be a +4 in order for those charges to balance, or those oxidation numbers to balance out. So that is it for oxidation numbers. I hope this video helps. You really do need to practice and do just a little bit of this so that you're prepared to do the complex balanced redox reactions, which we will discuss in class. Good luck. Hope things are going well. Take care.